We continue with the next example, in which we are going to have some real input and output from and to the console. The next example is called console echo.asm. Instead of taking a look at the code, let's begin by actually assembling and running this program. It seems like the program waits for input. Let's give it, for example, hello world. Now I press the return key. I got as a result, hello world. Let's try something else. I run the program again, this time with 1, 2, 3, 4. I get as a result 1, 2, 3, 4. This program just echoes to the console whatever I write. Now let's take a look at the code. Maybe let's begin by taking a look at the import section. This is the iData section, which is the import section. Again, we declare that we are going to use kernel32.dll. However, this time, as opposed to the previous example, we use more functions. We want to have access to some new functions which we haven't seen before. Get std handle, read file, write file, and finally exit process as usual. We already know what we use exit process for. We can see it here at the end of the code. Let's read the code. We begin by calling getStdHandle twice. This is the first time, and this is the second time. GetStdHandle is a function that allows us to get some handle or some access, for example, to input or output. In those two calls to getStdHandle, we get access to the input handle and also to the output handle. Note that after we call this function getStdHandle, we get the handle inside EAX. Then we have to keep the result somewhere. We chose to keep it inside the dword input handle, which is inside the BSS section. We did exactly the same with the output handle, but this time we kept the result inside output handle, which is also in the BSS section, here. Basically, this function getStdHandle gives us some access to the console. The functions which we are going to use next will have to know the input handle and the output handle. This is why we have to get those handles in the beginning. Next, we have a call to the read file function, which is here. This part is going to read a line from the console. As you can see, read file has many arguments. In this example, 5 arguments. Let me skim the arguments. The first one is called lpverlapped, and it is optional. This is why we put 0 here. We don't really care about this argument at this point. Next, we have bytes read. This is some location in memory where the amount of bytes read from the console is going to be kept. This is pretty useful if we want to know how many bytes we read from the console. This dword, of course, is declared here, inside the BSS section. The next number is called max input size. This number is a constant which we have defined before. We defined it here. It is the maximum number of bytes which we are willing to read from the console. If the user gives us more than this amount of bytes, the input will be cut. Let me show you the effect of this. I open the console, and now I run the program. Run console echo.exe. Now instead of writing something short, I'm going to give it some longer input. The result I get is cut, because only the first 20 hex bytes are considered. The rest are discarded. By the way, the next bytes could be read if you use another read file function call. Let's continue with the arguments. The next one is called input start, and this argument is pretty important. This is the address of the buffer to which the result is going to be kept. This is where the input from the user actually is saved. Input star is declared inside the BSS section, and it is of size max input size bytes. Finally, we supply the handle, the input handle. This is the handle that we got from the call to get std handle above. Then we call read file. We expect read file to do a few things. First, we expect the result to be inside input star. We also expect to have the number of bytes read inside this dword, bytes read. Finally, we have a call to write file. The write file function really does the opposite of read file. Instead of reading from the console, this function is going to write to the console. Let's take a quick look at the arguments. This argument, which is really the last argument, if we try to write the function in the C syntax, is really the same as this one. It is optional, therefore we just supply 0. We don't really care about this argument. Next we have bytes written. This is really like bytes read. However, this argument is going to contain, after write file was called, the amount of bytes actually written to the console. Sometimes write file will not be able to write all the bytes that you want, and in those cases you will know about it by checking the value of bytes written. Bytes written, just like bytes read, is declared inside the BSS section. Next we have this number, which is called number of bytes to write. For this value, we use the value bytes read. We already know how many bytes we got as input. We can just use this value to send the output to the console. Next we have this argument, which is called buffer. This argument specifies the location of the buffer which we want to copy to the console. In this case, we just use the input string, which means that we just echo what we got as input back to the console as output. Finally, we supply the output handler, which is in this case the console. Then we call writeFile, which is going to write exactly the string that we got as input back to the console as output. Eventually, we exit the process.